What if an asteroid hit Earth tomorrow? Not in a million years, not a close pass. Impact. Tomorrow. What would actually happen? The answer depends almost entirely on size. This surprises people. Most assume any asteroid impact means civilization ends. It doesn't. The range of outcomes runs from a spectacular light show to a mass extinction event, and the determining factor is a single number. How big is it? Let's start small. In 2013, an asteroid roughly 20 meters across entered Earth's atmosphere over Chelyabinsk, Russia. It never reached the ground. The friction of atmospheric entry caused it to explode at an altitude of about 23 kilometers, an airburst, releasing energy equivalent to roughly 30 Hiroshima bombs. The shockwave shattered windows across 6 cities and injured around 1,500 people, mostly from broken glass. The asteroid itself largely vaporized. A 20-meter asteroid is survivable. Unpleasant, but survivable. Scale up to 150 meters, and the situation changes considerably. An asteroid this size carries enough energy to flatten everything within roughly 50 kilometers of the impact point. If it hits ocean, which covers 71% of Earth's surface, it generates a significant tsunami. If it hits a populated area, it destroys a major city. The 1908 Tunguska event, caused by an object estimated at 50 to 80 meters, flattened approximately 2,000 square kilometers of Siberian forest. An object twice that size would be proportionally worse. At 150 meters, we are in regional catastrophe territory, not civilization ending, regional. Now scale up to 1 kilometer. A 1-kilometer asteroid carries kinetic energy on the order of 100,000 megatons of TNT. The impact crater would be roughly 15 to 20 kilometers wide. The immediate blast would be catastrophic across a continent-scale area. Debris ejected into the atmosphere would cause global temperature drops within weeks. Crop failures would follow within months. The cascading effects on food systems and infrastructure would be severe enough to threaten global civilization, not through the impact itself, but through the cold and darkness that follow. We are now in civilization-threatening territory. The dinosaur killer was bigger. The Chicxulub-impactor, the asteroid that ended the Cretaceous period 66 million years ago, was approximately 10 to 15 kilometers wide. The impact released energy equivalent to roughly 1 billion nuclear weapons detonating simultaneously. The initial blast, the earthquakes, and the global firestorm from re-entering debris were devastating. But the extinction mechanism was the impact winter that followed. Sulfur and debris ejected into the stratosphere blocked sunlight globally for months to years. Photosynthesis collapsed. The food chain collapsed from the bottom up. Approximately 75% of all species on Earth went extinct, not in a single moment, but in a geologically rapid collapse that unfolded over tens of thousands of years as ecosystems unraveled from the bottom up. A Chicxulub-scale impact tomorrow would be an extinction-level event for human civilization. Now, about tomorrow. With 1 day's notice, our options are essentially zero. Every meaningful planetary defense strategy, kinetic impactors, gravity tractors, nuclear deflection, requires years to decades of lead time to alter an asteroid's trajectory enough to matter. A 1-day warning is enough time to evacuate a city. If we know precisely where it will hit, it is not enough time to stop it. The honest answer to planetary defense is that we currently track approximately 95% of near-Earth asteroids larger than 1 kilometer. For objects smaller than 140 meters, our survey coverage drops significantly. The asteroid that hit Chelyabinsk in 2013 was not detected before impact. So what would actually happen tomorrow depends on what is hitting us and where. A small asteroid over the ocean, a news story. A medium asteroid over a city, a regional catastrophe requiring international response. A large asteroid anywhere, the beginning of a very long winter from which civilization might not recover. The size is everything. The location is luck. And somewhere out there, moving through the dark at tens of kilometers per second, are objects we have not yet found. We are, statistically speaking, overdue for a Chelyabinsk-scale event. The good news is that we are not overdue for the other kind yet.